Assalamu alaikum wa rahmatullah. Welcome to the 11th video. In this video, we will explain satellite and weightlessness. Okay, here what they are trying to tell us is that the people and all the objects in the satellite, it is possible for them to experience weightlessness, meaning they feel weightless. They can float in the satellite without feeling their weight. And this happens in the elevator. In the previous video we explained that when an elevator is falling freely under gravity with acceleration equals g, then the man in the elevator experiences weightlessness, meaning he doesn't feel his weight. He can float in the elevator and the scale inside will record zero weight. Okay, so this means that it is possible for people and objects in a satellite to also have zero weight. Okay, that is weightlessness. And it happens when the satellite is launched, and then instead of the satellite to follow the direction of the launching velocity, uh, due to gravity, it bends and moves along a circular orbit. It means without the gravity, it will just, if it is launched in this direction, without the gravity, it will just follow the direction of the launching velocity and move in a straight line. But because there is a force of gravity pulling it down here, this force of gravity will cause it to bend and move along this path. Okay, uh, it means that the gravitational force will provide the centripetal force required to keep the satellite in the orbit. And when this happens, the people in the satellite and the object in the satellite will have an apparent zero weight. Okay, they will have weightlessness, they will experience weightlessness. This is what they are saying in a nutshell. And we can say that centripetal force mv square upon r will be equal to the weight mg. So mv square over r is equal to mg, where r is the radius of the orbit. From here we can see that m can cancel m, and we can use this equation to determine the velocity of the satellite in its orbit, or even use it again to get the radius of the orbit. Okay, okay. Here is a quick summary of what we learned from this topic. The first one is momentum of a body is defined as the product of its mass and its velocity, meaning when I multiply mass of an object by its velocity, I get its momentum. Secondly, the impulse is the product of force and the time during which the force acts. If I multiply force by the time during which that force acts on an object, this measurement we call it impulse. Now, sometimes the force is large and it acts for a very short time, and sometimes the force is small and it acts for a long time. Any Either of these two, the impulse is great. I can have a large force acting for a very short time, or a small force acting for a long time. Impulse act only for a short time. I'm trying to debunk this idea. It's not always true. Force, you can have large force acting for a very short time, or small force acting for a very long time. In either of these two, impulse is great. Then here is a summary of the Newton's laws of motion. Here is the first law, which we know as the law of inertia, and then we have the second law that gives us the ability to calculate force, F equals ma, and we have the third one, the third law that says action and reaction are equal and opposite, and then the fourth thing here is the principle of conservation of linear momentum, which states that when two or more bodies act on one another, meaning they collide, their total momentum remains constant, provided there are no external forces acting on the bodies, and such a system of bodies is called an isolated or closed system. The fifth point we should remember is that in elastic collision, we say that collision can be elastic, it can be inelastic. In elastic, both linear momentum and kinetic energy are conserved, but in inelastic collision, linear momentum is conserved, but kinetic energy decreases, meaning it's not conserved because the kinetic energy is converted into sound, heat, and possibly light energy after collision. Number six, mass is the quantity of matter in a body. That is how mass is defined. Also, mass is a measure of inertia of a body. We don't have a formula to calculate inertia. We only rely on the mass. If the mass is great, it means inertia is great. It means resistance to motion is great. If the mass is small, it means inertia is small, and it means resistance to motion is small. Okay. Also, force is proportional to acceleration, and the the constant of this proportionality is the mass. F is equal to ma. Finally, the weight of a body is the force with which the earth pulls the body to the earth's center. Meaning, when we say weight, we are talking about the force that gravity exerts on an object. Okay, here are the exercises. Let's see how we can solve the exercise. The first one says a ball of mass 0.5 kilogram moving at 10 meters per second collides with another ball of equal mass at rest. The second ball also has this mass. If the two balls move off together after the impact, calculate their common velocity. Okay, here is what you should do. Initially, the first ball is moving with this velocity, so its momentum will be 0.5 times 10, which will give you 5. The second ball was at rest, so it has 0 momentum. So you now say the momentum of the first ball plus the momentum of the second ball, which is 0. It will now be 0.5 times 10, 5. 5 plus 0 will now be 5. So 5 is the momentum before collision, 5 kilogram per meter per second. Now, after they collide, they are now together, so you need to add the two masses. 0.5 plus another 0.5 will give you 1. Now, their total mass is 1. You multiply by their common velocity to get their momentum. So 1 times v will be v. V is the momentum after collision. So using the principle of conservation of linear momentum, total momentum before collision equals total momentum after collision. So before collision it was 5, after collision it was v. So you now say 5 is equal to v. So that means v is equal to 5. And your answer should now be C here. In the second one, they said a ball of mass 5 kilogram moving with velocity this collide with another ball this moving in the opposite direction with this velocity. Okay, before they collide, the momentum of the first ball 6 times 10 will be 60, and the momentum of the second one 2 times 5 will be 10. But this should be negative because it is moving in the opposite direction. So you have 60 minus 10, and this will be 50. So total momentum before collision is 50. Keep that in mind, 50. After they collide, they are now together. You need to add their masses. 6 plus 2 will be 8. Now multiply this by their common velocity. You have 8v. So 8v is equal to 50. Total momentum before collision equals total momentum after collision. Before collision, you had 50. 60 minus 10, 50 is equal to after collision, you have 8v. 8 from their total mass, 6 plus 2. And then v, the common velocity. Now 8v is equal to 50. You divide both sides by 8. So 50 divided by 8 will give you 6.25, which is B. You see, we have solved it. In the next video, we will talk about work, energy, and power. And clearly, it's a new topic here, work, energy, and power. Thank you for watching.